Hello everyone and welcome back to the chess game lessons that I am making. I don't even know what to call them yet. If you have a good name for them, then please do post it in the comments down below. I might use the name that you've said and say your name out on the channel, which is reaching close to 100 subscribers now actually. Hopefully it doesn't go over that once this video comes out, which would be kind of embarrassing. So, a few things that I was thinking about in our program. First of all, how does the user know how to use our program? We need to tell them what is actually happening and how to make a move. So I was thinking, why don't we add another function? I need to still add the things in front of the function, but it doesn't matter. Function help. Just simply help. What the function is going to do, it's going to display details about how to play the game. There we go. We don't need to say anything more than that because it's all just going to be output stuff. We can decide what it is going to be later on. So what is going to be included in it? Just verbally I want to tell you it's going to be how to make a move, what it's expecting as input perhaps, how pieces are identified, and maybe to tell the player of that a pawn does actually have a P in front of it, and things like that. Everything else should be fine. I might not include too much detail when I'm actually doing it. It really depends on what I feel like, and yeah. If I think of something more, maybe I might add or remove later on. It's that function isn't that big of a deal. It's just, I feel like we do need it to tell the user. So where do we want to implement this help function? Well, we want to put it again in the else over here, just to tell the user of what they might be doing wrong, how to do it right. There we go. That's one place I want to implement it, and another place I want to implement it is, well, before we actually start, so help how to actually play the game. Now thinking back to it, I probably also want to clear chessboard just before I do that, just so that the chessboard is actually set up and everything is fine. So clear chessboard, with that I need to put in which chessboard. The chessboard I want to clear is called chessboard. There we go. Should be fine. So that's going to set up the chessboard. Then it's going to give the user some help. So show them how to make moves. And then maybe perhaps I want to display chessboard. I think it will, yep, just display board. There we go. Display board. Parentheses. So what this is going to do, it's going to be like an introduction. So when the program is started, the chessboard is set up, the user is told how to play the game, and then they are shown the board, so that they can start thinking about the game. And then later on we also have the help and showing the board and stuff like that as well. Another thing we might want to implement with our new help function is maybe we might want to put it in here, although that might be annoying as I'm planning on making it quite longer, so maybe not there. For the input, I might want to add another else if here. Capitals else if piece input equals help or something similar. We can decide on that later on. We give the user the help they are asking for, and that can also come here. Good indentation. There we go. That is fine. And now when the user wants help, when they don't know what to do, well, not which piece to move, but help as in how to do it, that should be easily accessible. In theory and logically it makes sense, at least to me. If it doesn't to you, then tell me in the comments. Once we get to the program though, we will see whether it's correct or not as well. Another thing I have been thinking about was perhaps making a dictionary isn't the best choice because of calculations. So I'm kind of going back to the initial idea of a list here. List, oops, list, and I can just copy and paste that. The reason why is because of what we're going to be working on today mainly for check valid move. We're going to have to be doing calculations, and calculations are difficult to do with letters from A to H. What's also going to help us out is this. So if you don't remember from the Python course, then I don't blame you, it's been a while. What we can do is, using these functions, we can get the ASCII number of the certain letter that is associated with it in ASCII, or vice versa. So if we give the, let's see, so get the ASCII number of a character. So what this does is, if you give it a character, it gives you its number in its ASCII number. The other function, the cr function, when you give it a number, it gives you the character. So here what we can do is add to the character or take away from the character, and then still have it as a character. So because of in the input we are going to be asking for letters, not just numbers, because that might be slightly confusing. We want it to be as user-friendly as possible for now. So we're going to be asking for letters. If we get the letter, for example, 97, which is a lowercase a, from that we can take away 97, and then we get to 0, which is going to be going back to this position, or at least this column. And then we identify the other thing by this. So from each of the letters that we take in, we take their ASCII value and then take away 97. So for A would become 0, B would become 1, H would become 7. H would become 7. Then for the row numbers that we get, we take away 1 from each, so that we can use it as a list. Because as we all remember, lists start from 0, not from 1. And that, I think, should work. And that's going to be much easier to do because, as I mentioned before, calculations are easier to do with numbers than they are with letters. And with letters, you would require a lot more conversion between ASCII and numbers, I feel. So why don't we actually start on checking for valid moves? I think that I'm going to start on the rook. So where is rook? Here's the rook. Let's think about it on our little board that we have made. Oops, I did not mean to do that. I added a few numbers over here, and those are not correct. 1 second. Okay, now that I corrected it. So this is what our lists are going to look like when we set them up, or at least how they should do. How I plan on making them look. So a rook can be anywhere, because it can be moved anywhere. You can move it whichever way you like. Let's imagine it's here. Just imagine, for now it really doesn't matter. Capital R, because we're looking from the white's perspective. So where can it move? It can move to the right, it can move to the left, oops, it can move to the left, it can move up, and it can move down. So what does that relate to in terms of our numbers? So our rook has a current position in our list of 3, 3. If we decide to move up, then we can only change the row number. If we notice a change in both of the numbers, then we can say that the move is invalid. If we only notice a change in one of the numbers, then we can say that the move is valid. So that's the conditions that we want for moving a rook. We want to see a change in at least one of the numbers, but not in both of the numbers. So, or no, we want to see a change in one of the numbers, but not both of the numbers, and not neither of the numbers, for a rook move to be valid. So, why don't we write that down? Where's our rook? I do hope that that makes sense. If it doesn't, do ask in the comments down below. I honestly hope so, because if you're moving it to the right, then this number stays constant. However, this number changes. if you're moving up, so if you're moving up or down, this number changes, but this number stays the same. The same horizontally as vertically, which is why I said what I said. So the way in which we are going to check validity for movement of the rook is we don't have to make it as complex, written really complicated in a complicated way. You can just say if row, and so we can say if row changes but column doesn't, or column changes and row doesn't, then it's valid. So if column how do we want to word this? If column number, we can just call it that for now, column number dot change. We can have a new method says change, which compares the old, the old position with the new position. So we have a new method in here then in our piece, because that's going to be all across our pieces. Method change it is change, because it should return boolean is change, and we can just leave it as that for now. We're going to be using that as comparison. So if column number changes, I'm actually just going to do it in words. If column number changes and row number, I'm going to use underscores actually, number stays the same, or vice versa, column number stays the same and row number changes, then we say that this is a valid move. Return true. True meaning valid move. Anything else, false. This and needs to be capitalized. So column number changes and row number stays the same, or column number stays the same and row number changes. We want to make sure that if neither of them change, that it also returns false. So we also want to make sure that so we can have this in brackets or parentheses, and also compare that to and column number not, so column number not how do you want to say it? Not stays the same, not doesn't stay the same, and something else, and row number doesn't stay the same. So this is a really simple way of putting it. I know it's not a really pseudocode, however it is quite close to English, and that is all we care about. We can easily put it into programming later on. So that's the rook done. We know the logic of how the rook would move. Let's move on to the bishop, because once we have the bishop and the rook, we can easily do the queen. So how would a bishop move? Say we have a bishop over here. Now it's slightly more complicated than a rook, because we want to observe a change in both the column and the row. However, they have to be by a different, the change, when you divide the change of one by the change of the other, you always have to get 1. Because if you go from 3 to 4, when you're going in the columns, And when you go from 3 to 2, when you're looking at the rows, you've changed 1 in both. And when you divide 1 by 1, you get 1. Let's look at another situation. If you go with the bishop to this position, why wouldn't it work? So you've changed your, let's call it X and Y, I think that would make things easier on me. You've changed from 3 to 7, that's a change of 4. You've changed from 3 to 0, which is a change in 3. 3 minus 0 is 3, 7 minus 3 is 4. Dividing 4 by 3, you get, 4 by 3 you get 1 and a third, which isn't 1. Therefore, that's an invalid move. However, if you try to move the bishop to here, to 0, 6, then what happens is 3 minus 0 is 0, 6 minus 3 is 3. 3 divided by 3, you get 1. So we can do that kind of maths. If we, thinking back to earlier, if we had letters here, that might be slightly more difficult. It is doable, but it might be slightly more difficult. I think that this is the best way of doing it. So let's try out other possibilities. So if we try to move it to there, what happens? Then we get 3 minus 2 is 1, and we have a change of 0. So dividing by 0, that's not allowed. It's again invalid. If we keep it in place, we're dividing 0 by 0. That's again not allowed. So we've even solved the problem of keeping staying on the same spot with the bishop. That's not allowed. So that looks all good to me. So now let's just put it into our code. Let's implement it. Let's find the bishop. Here we are. It also really doesn't matter which one you take away from which one. We can check for either positive or negative 1. We can just take the absolute and check it as 1. So what absolute means is taking any negative number and making it positive, and a positive number just stays positive. If we want to, we can't even make our own function of that, but I'm pretty sure the Python has that implemented. If it doesn't, it's not too difficult. We just check if the number is less than 0. If it is less than 0, then we multiply it by -1. If it isn't less than 0, then we just keep it the way it is. Search up absolute on the internet. It shouldn't be that difficult to find out what it means. So where was the rook? I was just looking at, or no, not the rook, the bishop, sorry. So here's the bishop. Let's fix the bishop up. So if column change, I believe that's what I'm calling them. Column number. I probably want to call these variables quite good names. So I want to have new column number, old column number, new row number, old row number. I think that I'm going to change that to that, and while I'm not recording, I'm going to change it in there as well. So for now, let's just look at this. If column number, so if new column number, I think that I'm going to do like this, new column number minus old column number I can put that in parentheses because I want to divide it, and because of bitmass it wouldn't work otherwise. Divided by the same thing, but instead of columns we can have rows. New row number, old row number. If that is equal to, just to make sure, I'm also going to put another pair of parentheses over those, is equal to 1 or -1. I can't even put it just simply like that. -1, again, just to make sure, I'm going to put parentheses around that. Then Also, another thing about pseudocode which I remembered, instead of the colons, you might sometimes see literally the word then. It really doesn't matter, it's pseudocode. Again, you can do it the way you want it to, as long as it logically makes sense. As I said before, you can even use a flowchart as pseudocode. So we've checked that. Then we want to return true, because if it is 1 or -1, then it's a valid move. Else, everything else is an invalid move. Return false. Oops, not false, it should be return false. I was just looking back at that, just to make sure that I had the correct thing. So that's the logic for the rook and the bishop done. I was just looking at the time and we're above the 20-minute mark. I don't really want to make it any longer. So what I'm going to leave you with is a bit of homework for this. So now that we have both the bishop movement, so the bishop movement and the rook movement, how can you implement both of those into the queen movement? Where is our queen? Let's just find it. Into the queen movement. Because the queen is like a mixture between the bishop and the rook. So how would you implement those? If you give me the correct comment, it doesn't have to be in pseudocode, it can be in either code, it can be in pseudocode, it can be explained in normal English, I don't mind. I will like your comment and mention your name in the next video, if you would like me to, of course. And I don't see why you wouldn't want me to. I mean, my channel is growing, right? I'm getting big on YouTube now. I'm a big boy. So other than that, I will leave you there. I don't want to go too much over the 20-minute mark. If you enjoyed this video, please give me a like, share, and subscribe. Hope you're enjoying this new series that I've come up with. And yeah, until next time, thank you so much for watching, and goodbye.